If you're anything like me, you probably use YouTube for learning all kinds of stuff. There are these fantastic creators on YouTube that create hours of content across hundreds of videos on your favorite subject. Wouldn't it be cool if you could just take the AI clone version of that YouTube channel and ask any question and get results just as if they were sitting with you in person? Well, that's exactly what I'm going to show you how to do today. We're going to take the YouTube channel of one of my favorite YouTubers and build a chatbot on top of it that allows you to ask questions of the entire channel. Now, while in the thumbnail I use Andrew Huberman, who makes content around health, I thought it would be more relevant to do something around AI, which is why I chose Matthew Berman's channel. Matthew, almost on a daily basis, covers everything from the latest AI news to getting hands-on with code, interviews with some of the brightest minds in AI, and it's just been an amazing resource to stay on top of all the changes that are happening in the world of AI. So without further ado, let's just start chatting to his channel. And I'm going to choose one of these videos. This one, run any open source LLM locally with LM Studio. And we're going to start chatting with it. Now, I have multiple fields here in order to support chat, but we can just ask a question. So what does Matt think about LM Studio? And what is the newest feature LM Studio has launched? So we'll give it a sec. Matt thinks LM Studio is awesome, especially for beginners. The newest feature is the ability to run multiple models simultaneously, which is accurate. Let's run a few more. He has another video where he breaks down the thoughts of Jan LeCun around the achievement of AGI with LLMs. Jan LeCun has a Turing Award as one of the biggest figures in AI. So let's see what he thinks about LLMs being able to reach AGI. Jan LeCun believes that LLMs won't be able to achieve AGI because they lack essential characteristics such as understanding the physical world, persistent memory, reasoning, and planning, which is in fact something mentioned in Matt's video. Let's do a few more quick ones. Tell me about Disney's new robot. So here we can see it's telling us it was made by the team in Zurich with mostly 3D printed material and given a unique character. Now, we are using OpenAI in the background, but because of the training cutoff, it doesn't have information such as the latest news around a robot that Disney launched. So this is coming straight from Matt's video. And lastly, let's do a question on this new jailbreak method. I'm not even going to give it a lot of context. I'm just going to say, how does the new jailbreak method work? Alright, and we see the new jailbreak method works by crafting cloaked prompts that visually encode identified words to trigger responses that fulfill malicious users' objectives and induce unsafe behaviors from the victim LLM. So this comes from Matt's video where he explains if you just say, show me how to make X, and then you say X is equal bomb, but you provide bomb in ASCII, it will actually comply with your request and show you how to do that. Pretty interesting new jailbreak method. Now, before we dive into how this was made, I want to highlight that this isn't only for talking to YouTube channels. Creators can actually use this as a new distribution method. So just as you have email lists and you know how important those are to growing your business, in this new age of conversational AI, you can have chat lists where your entire audience is on chat and able to speak with your AI clone, and you can very tactfully introduce your audience into steps of your business funnel at the right moments when it is most relevant. For example, if I was Matt and someone was asking about X, I could just answer whatever I know about X. But if I had a particular affiliate link associated with Y, when they ask about Y, I can say, yeah, Y is cool. You know, here's how you use it. By the way, you can get your own here. And I can provide an affiliate link. Or similarly, you can drive them to another lead magnet you have for like a course or whatever else that you have going on in your business. And this is going to have a conversion rate that you're just not going to see with any other medium because it's highly contextualized, it's highly personal, and it comes at a point where you've provided a ton of value with all the knowledge that's available from your AI clone. So if you're someone that has a large audience, I would strongly recommend that you start looking at building a chatbot clone of yourself where you can provide value at scale to your audience and at the same time helpfully guide them to your right products or services that would help your users accomplish their goals. So how do we build this thing? The astute among you will have noticed that this is nothing other than a Retrieval Augmented Generation use case, otherwise known as RAG. Broadly speaking, it's comprised of two stages. One stage is for waiting for new YouTube videos to be published, and once they're published, to take this transcript and put it in a database somewhere. And the second stage is actually interacting via a query interface or a chatbot with that data using an LLM. In order to understand the code better, let me first give you a high-level overview of both of these stages. The initial step of putting the YouTube transcripts in a database is called indexing. It's called indexing because just like in a book where you go to the index and it tells you which page to go to, databases can do a similar thing with chunks of the transcript. So to put this whole thing together, we need the program to sort of wake up at some interval, let's say every hour, check the YouTube channel for any new videos. We'll do this using the YouTube API on Google Cloud. And if a new video is posted, then we can get the transcript of that video using some Python library. Then we take that long transcript and we split it into chunks. So maybe an hour-long transcript might be thousands of chunks, and a 5-minute transcript might be just a couple chunks. We are chunking the transcript because when a user asks a question, we only want to give the most relevant chunks of information to the LLM, like ChatGPT, in order to provide the answer. If we were to just dump the entire transcript into that question that we're asking, then we'd be spending a lot of extra money, not to mention LLMs don't actually do that well when you give them a ton of context. Finally, we take these chunks and we put them in a vector database. I chose to use Pinecone because they have a serverless offering, which actually works pretty well, but there are dozens of other vector databases available for you to use. Now, I did mention that there is a scheduler, so the code does have to wake up at some interval and check for new videos, and you could use something as simple as a cron script, or if you're using some online services, you can say, run this bit of code every hour or so. But we're going to be using Dagster, which provides a lot of additional benefits than using something like cron. Namely, it allows us to recover from failures and run some like backup scripts if something goes wrong, or we're able to backfill certain days. Let's say the YouTube API is down for a day or two, then we could say go back for those days and fill in the data for the days that we missed. And this is just the type of tool that you would actually use in production. So I wanted to show you how that is put together. Now, the second part of this, which I already kind of alluded to, is how you actually interact with the data that you just stored. This is the end-to-end query and response, where you ask a question like, tell me about the latest robot from Disney, and a bit of code in something like the LangChain framework goes and queries the vector database for all the relevant chunks that might include keywords like Disney or robot, or something semantically similar like, I don't know, cyborg or something like that. And it returns the most relevant chunks. You take the top N, or traditionally the top K of these chunks, and you just append them to your prompt. So you might say something like, what is Disney's latest robot? Use the context provided below to answer the question. And then you can say context, and then you literally just paste a bunch of different chunks of context that will help the LLM answer the question. You pass all of this to an LLM like OpenAI or your own local open source model, and the LLM will then be able to give you a response grounded in the pieces of context that you provided it from the vector database. All right, with all that said, let's get started and get this running on your machine. So you're going to want to come in the repo, which I will post the link to in the description, and go to your favorite terminal and just clone the repo. So you can do that with git clone. And when you go in that folder, there is a full README, which walks you over how to get everything ready. You're going to need Poetry, which is sort of like pip, but with a little bit better handling of dependencies. And you can install those dependencies by doing poetry install. That'll take a moment. Now, there are a couple things you'll need in order to run this project. The most obvious one being the YouTube handle that you're interested in. Show me the data is my YouTube handle, but you're going to want to go in the .env file in the folder and just replace it with your channel of interest. So for Matthew Berman, it would be everything after this @ sign. So I'm going to copy that and go to my favorite editor, and the env.example file, you can just rename that to .env, which will automatically set the environment variables for you. So you can just place that right there. Then you have 3 other things that you'll need. The OpenAI key. So you just go to platform.openai.com/API keys, and you can create a new secret key, give it a name, and copy that and paste it in here. You will also need a YouTube API key. To get that, you'll go to console.cloud.google.com, which is just Google Cloud Platform, and you're going to register. You can get started for free, so you don't need to worry about paying for anything. Once you're there, you may be prompted to create a project, and from there, you can just go to this menu here, all products, and go to APIs and services. You're going to have to enable the YouTube data API, which I already have. But if you wanted to do it yourself, you would go here to enable APIs and services, select your favorite service. I'm just going to choose a random one like the Places API and click enable. After you've done that, you're going to see something like this where it'll take you to the manage page where you can create credentials. So on this tab here, credentials, you can click that, create credentials, you can create an API key, and that'll give you an API key which you can just copy and paste in your environment file. You're also going to need a Pinecone API key, which is the vector database I'm using. And as you can see, they have a serverless version, which is perfect for this project. So you can log in. So you can go ahead and create an account, and from there you can go to API keys and then create an API key. You can give it a name. And when you click create, you should see it over here, and you can copy it right there, or you can take a look at what it is. Copy that, paste it here. One last thing you'll have to do in Pinecone before you can run this is you can go to indexes, which you can think of like databases, and you can create an index. You have to give it a name of YouTube videos, which is what we use in the code. Of course, you can change that later. And here you have to configure the dimensions of your embedding. So the numbers that are going to be used to match the user's query with the documents in the database, they have a certain dimension. And you can just say set up by model and use text embedding 3 small, which is what I have hard coded in the code. Of course, if you want to change the embedding, you're free to do that, but I found this to work pretty well. So you say set configuration and you choose your region, east or west. So you want it to be close to your users, and you just say create index, and that's it. You should be ready to go. And last but not least, we have the LangChain API key. This isn't strictly necessary, but it will allow you to trace all the different calls that are happening with the LLM using LangChain and be able to break down the costs and things like that, kind of sort of see under the hood what's happening. The piece of software within LangChain that's used to do that is called LangSmith, and it's super useful. So for that, you want to go to smith.langchain.com and come here and in settings, API keys, and create API key. Again, give it a name, create it, copy, and paste. So just to review, you're going to want to paste all of that here, and if you want to use LangSmith, you want to uncomment these lines here that start with LangChain, and you're going to want to rename the .env.example to just .env, which will now allow those variables to take effect. Once you've done that, you can just go to your terminal and say make Dagster UI, which will run this command right here, poetry run Dagster dev, which spins up a UI that shows all the jobs that we've configured via Dagster. So you can see it tells us we can visit that page here. And when we go there, we can see all the different steps in our job. So first we get the video IDs, then we get the transcripts, then we index the transcripts. And you can get to that screen by going to Assets and then clicking View Global Asset Lineage. Now, if you've never used Dagster before, or you're used to using something like Airflow, Dagster is gonna feel like a breath of fresh air. It is so easy to use, and it is built for modern times with modern data engineering workflows. I cannot recommend it highly enough. One thing that I really like about Dagster is that instead of something like you would get in Airflow, which is viewing everything as a series of tasks of arbitrary compute, you have first-class support for the assets that you're building via those jobs. And what that allows you to do is build those assets within a job in Dagster, or even have it externally materialized by some other process. So it is super smart, and you're not going to regret using Dagster, and you'll probably never go back to other tools after using it. So at this point, we have our jobs here, and I'm just going to show you how you might use the UI to materialize it or play around with it as you're getting started with this. So you can just select the assets that you're interested in materializing and just say materialize selected, and you can jump to that run. And here you can see a real-time report of how that execution is going, including all the different wait times. Down here, we have the logs of the various jobs, and it is super smart in that you can emit any kind of metadata from your jobs that you can later filter your jobs on. So here we can see that in the transcripts job, it was going through all the videos that we listed with the YouTube data API, and it was checking in our Pinecone database to see if we've already indexed them and skipping them if we had. At the end of this job, we can see that the newly indexed videos are blank because I have run this on a schedule in a server somewhere, so there's no new videos to index. And we can see that the job is done. Now let's see how this job was put together in code. So if we hop to the project and go in the assets folder, you can see that all those different assets are nothing but a simple decorator on top of regular Python functions. So this decorator comes from the Dagster library, and you can see that we're just writing regular Python code here, where we're using the YouTube data API key to fetch the channels associated with that user handle, and recursively just getting the video IDs, which we will then return as an array at the end of it. So by returning the video IDs here from a function called video IDs, we can instantly use that in our next task to generate our next asset, which is the transcripts of those videos. You can see in this function, I'm passing in video IDs as a list of strings, and because the name matches, it automatically wires those together and passes in the output of that previous function into this function, which you can just go on and continue to use. In this case, I'm looking at my Pinecone database and seeing if that ID is already indexed or not, which is just a function I've implemented. And if it hasn't been indexed, we simply use the YouTube loader from the LangChain community's document loaders, which all it does is it grabs the transcript and some metadata for that video, and we just get those documents, and documents here are just the transcript with a little bit of LangChain metadata wrapped around them. We append those documents to this empty array here, video transcripts, which we're returning at the end of this function. So by this point, we are returning a list of documents. Finally, we're taking those transcripts from the previous step and passing them to this function called index transcripts, which is inserting them into Pinecone, our vector database. In order to do that, we first need to split the document into chunks that we are going to later retrieve. We're using the split text function to do that, and all that's doing is just choosing a certain chunk size with a little bit of overlap between the chunks, and just returning the new chunks from that document. We loop over those chunks and append some metadata, such as the raw transcript in this text attribute of the metadata, as well as other metadata like what was the YouTube title and things like that. We also have to embed the text from those chunks using this embed OpenAI function, which you can substitute with any other embedding function of your choice, which takes that text and maps it to essentially a vector or an array of numbers, which the vector database uses to find similar documents. Once that's all set, all we're doing is just upserting, which is update or inserting, into the vector database. Now, you saw me run this via the Dagster UI, but you can also just run this job as a one-off job that you can just trigger from the command line. To do that, you can use this make index videos command, which essentially just runs a headless version of Dagster and runs that job. So as you can see, it's just going through all those steps and running the job. So when that's all done, if you go to Pinecone and you go to your index, you should see all the chunks of your documents in the database. So you can see we have this metadata. So author Matthew Berman, the text. So that's just like a chunk of text from one of the videos of how to install Llama 2 locally. And you can see this values here, that's the embedding. So that's what we used OpenAI's embedding model to generate. And that is sort of a semantic representation of that text in numbers, which the vector database uses to find similar documents to the query that we pass it. And with that, we're ready to move on to the query side of our system. So on the query side, we're mainly dealing with two files. The first file is this serve file, which just sets up a fast API server. It's a simple API server that plugs into LangChain's runnable interfaces as provided by LangServe. And you can see all we're doing is just setting up the root server and just adding the route for /chat and passing in, which we will look at in just a second. And we also have a health check to know if your service is running or not. And now we can take a look at what this chain actually looks like. So first thing we're doing is instantiating the Pinecone database so we can interact with it. You can see we're using the same index name here, YouTube videos, and passing in the namespace. So I have one namespace per YouTube channel. And here we're telling it, when I give you a query, how do you turn this query into embeddings, which you can then pass on to the vector database to find similar documents. So you have to use the same embedding model that you used when you indexed the videos. In our case, it was the text embedding 3 small. From there, we're instantiating a LangChain retriever from that Pinecone database, and we're telling it to return 4 closest matching documents to shove into our prompt. And what does that look like? It's just this prompt down here. So answer the question concisely based only on the following transcript snippets from a YouTube video. Do not mention the snippets. If you don't know the answer, say I don't know. And we've optionally included a chat history if you wanted to incorporate this into some sort of chat system where you can pass the LLM all the context of the conversation so far. So if the user refers to something as the or it knows what it's talking about. So this is optional. And we can see that here we have snippets and we have this context variable, which will be filled by the documents returned from this retriever. So it's literally snippets of text from the database. So we pass that as the system prompt, and we pass the user's query or question as the next step in the prompt template. Here in this chain, we are simply filling in all those variables so we can pass it to this prompt. And we're telling it to use this model here, which is just our OpenAI model with temperature 0, which will reduce hallucinations as much as possible. And that's about it. This little bit of code is what allows us to chat with the YouTube videos. So to get this up and running, let's take a look at our makefile. We just have to do LangServe. That will spin up an application at port 8000. And we can see that by default, thanks to LangServe, we have 2 endpoints available here. So we can go to the /docs and /chat/playground. So let's take a look at that. And here we can see all the different endpoints that were set up just by using LangServe. So you can see, so there are a whole bunch of metadata endpoints that tell you how to actually structure your query to this endpoint, which is super useful. The /chat/invoke is the one that we're actually using to have that chat conversation. The batch allows you to do sort of multiple requests in batch. So in this scenario, it doesn't make as much sense. I should have probably disabled it. But for other scenarios, let's say you're processing a whole bunch of documents at the same time, you might want to use this batch endpoint. And we also have these streaming endpoints, which allow us to stream the output, the logs of everything that's happening, and of course the events, which are mainly useful for debugging or building tooling on top of the internal operations, and is what's actually used to power LangSmith, which is what I want to show you next. And the other endpoint that's available to us is this chat playground, which is what I showed you initially. So this is what's going to call that invoke endpoint. For example, does Matt have a newsletter? And where can I find it? So you can see it's in the link to in the video descriptions. And here you can see all the intermediate steps that are coming from that chain. So the last thing I want to show you is LangSmith. If you recall, I said if you go into your .m file and you uncomment these and you provide a LangChain API key, you will get access to some very interesting metadata. What that looks like is if you go to smith.langchain.com and you go to projects, you will see the name of the project that we are working with. In this case, it's this one here. And right off the bat, you see a whole bunch of useful metadata. For example, what is the latency? What is the total cost of running that thing? How many tokens were used? What is the error rate? And clicking in, you can see each individual run along with all of its metadata recursively broken down, which is very useful in debugging your application. So clicking into that last question I asked, we have that question about Matt's newsletter, and we can see what documents were returned from the database and all of their metadata. And we can also see what was passed to the LLM in the end. So you can see we have that system prompt and our chat history is empty, and our snippets are literally an array of documents with all the metadata and the text chunks built right into it. Another thing that LangSmith makes easier and will be a part of a production RAG system is creating custom data sets to use in evaluating your system. So in a production RAG system, you want to know when you make a tweak to a part of the system, such as increasing K from 4 to 6, how much does that influence things like the accuracy or the recall of the facts, or maybe the toxicity or the relevance of the answer or the quality of the answer in general? So that's beyond the scope of this video, but it's there for you to check out. Lastly, I want to show you a quick demo of how you can use this simple API to integrate it into some sort of chat system. So it's no secret that I love Botpress because they're so easy to use and get started with on their pay-as-you-go pricing. And here I've set up a very simple one-step flow to show you how to call this API. So in the terminal here, I have that server running, and I'm using ngrok to forward my local server to a publicly accessible address here. And here we can see that whenever a user types something in, all we're doing is just posting to that chat invoke URL and getting the response as the RAG answer and displaying it here. And the cycle repeats. Okay, so let's publish this bot and let's go here and try chatting with this thing. So here we go. Does Matt have a newsletter? And where can I find it? And we can see that it is calling the invoke API and returning the answer. So now this allows us to deploy this chatbot anywhere, whether it's like WhatsApp or our own personal website, and it can allow us to do those cool things like insert affiliate links or put forward some offers that we might have, like a course or something like that. Now that you're sort of familiar with the code, let's talk about how you can deploy this to a web service. I mean, it's great having it on your computer, but if you want to make this public, you got to deploy it somewhere. You need somewhere to run the jobs on a regular schedule, and you need somewhere to host the API. I like to use Render because they're very friendly for side projects and it's really easy to get started. So here we're just gonna create two things. Let's start with the job. So I'm gonna come here and go with cron job, and I'm going to deploy this from my Git repository. I'm going to connect it to YouTube RAG. I mean, the first time you do this, obviously, you're going to have to log in. Let's take a look at all the settings. I'm going to set it in East. We're going to leave everything the same here. To build the project, we're going to say make install. For the schedule, I'm going to say every day at 12 a.m. The command to run, we're going to say make index videos, which is the one that runs the job. We're going to set the instance type to starter, which will end up costing us about $1 a month. And for the environment variables, I'm just going to copy what I had from the .env file. Okay, I've added the environment variables and I can just say create cron job. And we'll see that it's going to check out that repo and start installing it. And in the meantime, I can go and set up the web service. So I'm going to click new web service, and similar to the other one, I'm going to click YouTube RAG and do that make install command. For start, we had make serve, and I'm going to click free. Now, this does spin down when there are no API calls made to it, but this is fine for the purpose of demonstration. Similarly, let's add the secrets from the .env file and create the web service. I'm going to go to my dashboard, and we can see that these are successfully built. I should have called them something different. They're both called the same thing, but this one with the timer is the cron job. So let's click in, trigger a manual run. We should see it start to spin up and start running our Dagster job. Now, I set this up as a cron job, but in a production system, you'd probably want Dagster running all the time as a service. This job seems to be going fine, and I can go and look at the web service now. We do see that our service is now live, and we have this accessible at that endpoint. So let's just go there and pop that right in, and we're good to go. We're live. When will we achieve AGI? AGI will not be achieved in a sudden event, but rather progressively over time, likely taking at least a decade or more. So this is from that Jan LeCun interview that Matt shared with us. And there you have it, folks. You should now be able to talk to any YouTube channel using chat. Now, this is just one example of a RAG system that involves indexing documents. And while there were a lot of moving pieces, this was actually pretty bare bones. Putting this into production will likely include a lot more work. As you saw, you'd probably have to do a proper deployment of Dagster, and you'd have to optimize those prompts, as well as generate a test and evaluation data set for you to know how well your RAG system is actually performing. A couple of tips I will give on dealing with this YouTube use case though. Some transcripts will end up being super long. So if you went and tried to shove an episode of Andrew Huberman's podcast into this system, it will likely break because those podcasts are 3 hours long. So what you might have to do for longer episodes is to take that transcript and actually summarize it, right? So you can break it into chunks and summarize each chunk before indexing it. Or you might completely rewrite those transcripts as questions that users might ask about it. And that way, not only are you condensing that information, but you're also making it more likely that when the user asks a query, that your vector database will return the right documents and the right chunks from that query. I know we touched on a lot of different pieces. We talked about Dagster, we talked about Pinecone, we talked about LangChain and LangServe and LangSmith. We sprinkled in some Botpress and Render, so I know it can be a lot to deal with, and it may seem a little daunting, but just clone the repo, take your time, go through each of those concepts. There are a lot of resources available on the internet. And of course, there's the comment section, which I'll be happy to help you with any hurdles that you may need to overcome. If there is one part that you would like me to dig much further into, do let me know in the comments, and I'll be happy to talk about it in a future episode. If you learned something from this video, consider giving it a like and subscribe to the channel. I post videos on cool AI projects and things that I'm playing with on the side that I will share with the world, and you'd be the first to know when the next video comes out. Thanks for watching, and stay curious.